Yo, hey everybody, in this video I gotta cover format specifiers in the C programming language. Format specifiers are special tokens that begin with a percent symbol, followed by a character that specifies the data type, as well as optional modifiers, such as width, precision, and flags. Basically speaking, it's a combination of a percent sign, a character, and optional modifiers to format the output. By using format specifiers, we can control how data is displayed or interpreted. Let me give you a demonstration. We've covered a little bit of format specifiers on the previous topic on variables. Let's say we have an integer variable of age. Set that equal to some age. Then we will have a float. This will be a price. Think of a price. $19.99. Let's say we have a double of pi. A double is also a floating point number, but it has double the precision. However, it takes up more memory. Let's set this equal to the first few digits of pi to keep it simple. 3.14159.26535. Then a char. Currency. Pick unit of currency. This has to be within single quotes. I'll pick American dollars. And an array of characters, also known as a string. Maybe name. Type in your name within double quotes. To display these variables using printf, we'll want to use a format specifier, that percent symbol. We'll display the age first. Printf, within double quotes, we will use the percent sign for a format specifier, then D for decimal, comma, our variable age. So D means decimal. This will output 25. For a float, the corresponding letter for the format specifier is F. Printf, %F, we will display our price. Oh, and then we need a new line character. I tend to forget. You probably will too. 25 and 19.99. And a bunch of zeros afterwards. Alright, now for a double, you have two options. We can either use F or LF, meaning long floating point number. Printf, % either F or LF. Then that new line character. We will display pi, our variable pi. F also works. You may see people use one or the other. However, when we reach the topic on accepting user input, we can use a function known as scanf, where you'll want to use LF, if we're accepting user input for a double, that is. So just to be consistent, for doubles I like to use LF for both output and input. It helps with consistency and readability. By looking at this variable, I know that this is a double. But for output purposes, F does work too. You can use either. You do you. Now for a char, that's a single character. We'll use %C. I will display currency. That's the name of the variable. There's our symbol. And then for an array of characters, also known as a string, you'll use S. Printf, %S. New line. Name. That's the name of our variable. And here's our name. Depending on what you want to display, the % sign is going to be followed by a given character, depending on the data type of what you want to display. And here's a few of the more common data types for beginners. Integers, floats, doubles, chars, and an array of characters, also known as a string. Now we do have a few optional modifiers. So between the % sign and the corresponding letter of the data type, there's special characters we can add to format the output. Here's an example. Here's how we can set the width when we display our output. This time we'll have three numbers, three integers. Int num1 equals the number 1. Int num2 equals 10. Int num3 equals 100. We'll use a few printf statements. We're displaying integers, we need to use %D as the format specifier. I'll add a new line, followed by num1. Then let's copy this printf statement and do the same thing for num2 and num3. We're displaying 3 integers. Now, between the percent and the letter, we can type in a number. The number that we place between these two characters will set the width. For example, 3. The width specifies the minimum number of characters to print. So now we're printing at least 3 characters. 1, 2, 3, including any spaces. So my second number of 10 has 1 space before it. And with 100, well, it does take up 3 spaces. If I were to change this to 4, let's take a look and see what happens. Now we're printing at least 4 spaces. 1, 2, 3, 4. You can left justify these values by adding a negative sign before the number. Now these numbers are left justified, and we have all the space after. You can also add leading zeros by preceding the number with a 0. Rather than having spaces before each value, we'll have zeros. Maybe num3 is negative. Negative 100. Let's reset these. Before the letter that corresponds to the data type, if you add a plus sign, if the number's positive, you'll have a plus sign. If it's negative, you'll have a negative sign. This could be good for accounting. Now we'll get to precision. We'll need some floating point numbers. Let's say we have the following prices. Price 1 equals 19.99. Float price 2 equals 1.50. And price 3 equals negative 100.00. To display some floating point numbers, we'll use the format specifier of f for floating point number, followed by a new line character. Let's display price 1, then 2, then 3. Here are the floating point numbers, our prices. The default behavior of C is to display 6 digits after the decimal when displaying a floating point number. Before the corresponding letter for the data type, you can add dot or period, then the amount of digits to display after the decimal. If we're working with prices, 2 would be good to display 2 digits after the decimal. For example, dollars and cents. So let's do 0.2 for each of these. That looks a lot better. We have 19.99, 1.50, and negative 100.00. If this were 0.1, we would display 1 digit after the decimal. Do keep in mind that the output will be rounded if we were to display it. So 19.99 becomes 20.0. Alright, so that's how to set the precision. Add a dot, followed by an amount of digits to display. And with what we've learned, you can combine width, precision, and flags together. Along with our precision of 0.2, I will also set the minimum amount of characters to display. For the minimum width to display, I'll set that to be 7. And then I'll add a plus sign. So any positive numbers will have that plus sign preceding the number. So with format specifiers, along with the corresponding data type, you can set the width, precision, and flags. We'll have more practice with this in the future. And well, everybody, those are format specifiers in C.